Hi, I'm Liam.
Hi, I'm Amin.
I'm Anish.
Hi, I'm Lorian.
And we're Group 8, Detection of Unlawful Drones. In recent years, consumer drones have become more available to the general public. This has led to a problem known as drone drops, where drones will fly into prisons and deliver contraband unimpeded.
Current anti-drone systems are tailored toward military applications, making them too dangerous for civilian infrastructure. Thus, for our project, our objective is to develop an integrated all-in-one system that can defend against this drone drop problem at a civilian level.
For our proposed solution, we have 3 concrete goals. The first one is to be able to track high-speed drone targets. Secondly is to employ a civilian-friendly disruption technique. And finally is to deploy a fully autonomous system.
For our prototype, we intend to prove a proof of concept. So in this, we will be tracking slow-moving targets instead of fast-moving targets, and we will also introduce a proof of concept disruption technique by pointing a laser at moving drones. And then lastly, we will also prove the potential of autonomous control.
Taking a look at our system, we start with our radar chip. The radar is USB powered, connected to one of 2 microprocessors located on the base of the chassis. On that same microprocessor exists the wiring for our 2 separate motors, one located on the very center of the base, responsible for horizontal movement, while the second is located on the upper block, responsible for vertical movement. Finally, the camera is connected to the second microprocessor through a ribbon cable connected to the CSI port. On this same microprocessor exists a wired connection that connects our server to the chassis.
Our system takes a 3-staged approach, starting with detection, followed by classification, and ending with disruption. First, the radar detects objects and sends their coordinates to the microcontroller, which then sends movement instructions to the motor. Then, with the chassis pointing at the object, the camera takes pictures of the objects, which are sent to the server. The server then analyzes those objects with the AI model, and then once the user clicks fire, the server sends a fire signal back to the microcontroller, which fires the laser or whatever disruption mechanism we are using in the system.
In the following clip, we can observe the behavior of the completed system. As the drone moves, the radar picks up the drone's location. The chassis is then aimed at the drone, and a picture is taken and sent to the server. In the top left-hand corner of the screen, you can observe the front end of our system. This displays the output of the YOLO V8 classification model, which is represented by the bounding box and confidence interval displayed on the frame. Additionally, you can see the fire button become more and more red, correlating to how confident the model is in its prediction.
From all of us at Group 8, we hope you enjoyed our presentation and thank you for watching.